Okay, so in this short video, we're going to be looking at the phase and lever rules. The phase rule is really important because it defines the conditions of equilibrium. It's one of those rules that when I first saw it, I thought people were just making up. But actually, these equations are derived directly from the Gibb's rules of thermodynamics. So the phase rule can be written P plus F equals C plus 2. So P is the number of phases, F is the number of degrees of freedom, and C is the number of components. Now, for solid state systems, we can generally ignore any significant vapor phase. So we can simplify this down so that P plus F equals C plus 1. This is what we call the condensed phase rule. But this simplifies further for us because in our systems, we're only looking at binary systems. And so C is always going to be 2 because we've got 2 components. So therefore, this simplifies even further for us. P plus F equals 3. So the idea of this is that we can look at any point on our phase diagram and determine whether it makes sense, because we can know what the conditions of equilibrium should be at every point. So for example, if we have the liquid phase up here, at all points in this phase field, we just have a single phase, liquid. So P equals 1. That means P plus F equals 3. That means that the number of degrees of freedom must be 2 in the liquid field. Okay, and that means that for every temperature and composition, we have a different state for the liquid. Also, in these two fields, we know we have 2 phases. These are the primary phase fields of A and the primary phase field of B. So if I label this up here, we know we've got A plus liquid in here and B plus liquid in here. So P equals 2 and F equals 1. So we only have 1 degree of freedom. Down here, we have 2 phases again. So P equals 2, F equals 1. Anywhere along the eutectic line, we have 3 phases. So P equals 3, which means we have no degrees of freedom. So that means we have to fix all of the variables to define the system at any given point.